All right, we're going to do some special factoring today. On the front side, what we're going to do is just factor. There's no equations on the front side, and then on the back side, we'll actually use these equations, or sorry, use these definitions to help factor and help solve some polynomial equations. Okay, before I start, what we have our perfect squares, which I'm just going to list for you really quickly. If I take the square root of any of these numbers, we get nice values. So 7, 8, 9, and 10. Okay, I'm just going to go up to 10. Now, what we also have are called perfect cubes, and that's actually what we're going to use today. So I've got 2 to the third power, 3 to the third power. So each one of these, if we take the cube root of this number, it's going to be a nice value. So I'm going to write these down, and you guys might want to have these handy so you can look at them. So if I take the square root, let me just pick one. If I take the square root of 25, that's 5. If you take the cube root of 125, that's going to be 5. So basically what we're adding into the mix here are perfect cubes. So let me just write that as a little example here. If I do 5 to the third power, it's 125. And if you take the cube root of 125, you'll get back a 5. Okay, so we're going to do sum and difference of cubes. These are going to be things to the third power in the expressions you're going to work with on this side, equations you're going to work with on the other side. So if I have difference of cubes, subtraction, something cubed minus something else that's cubed can be factored into a minus b times a squared plus ab plus b squared. And we're going to go through and talk about this here real quick. So if you look on my list over here, my first term is x cubed, and my second term here is 8. 8 is 2 to the third power. So I'm just going to rewrite this real quick. And I know this is going to look weird, but x to the third minus 2 to the third is what I really have going on here. And so in that formula right up above, everywhere I see the a, I'm going to replace that with x, and everywhere I see a b, I'm going to replace that with 2. So the factored form here, this would just be x minus 2. The a value squared would be x squared. In the middle, a times b would be x times 2, so it would be 2x. And on the end, b squared would be 2 squared, and so that would be 4. Now, if you guys want to check, you could multiply this back out, which I'm not asking you to do, but I'm going to do it on this one question here. So if we were to multiply this back out real quick, it should give us back what we started with. If you do x times x squared, x cubed, x times 2x is 2x squared, x times 4 is 4x, and then I'm going to go through multiply everything by negative 2. So I'm going to get negative 2x squared. Negative 2 times 2x is negative 4x, and negative 2 times 4 is negative 8. And you guys can see these both cancel, and all I'm left with is what I started in the first place, that x cubed minus 8. So you can check any of these questions. What I'm looking for my answer here is the factored form of this. So let's try another. If you guys are looking at that list, you see 27 on there. You also see 64. So this first term says 27x to the third. So I'm going to rewrite this real quick as 3x to the third. Now, in this situation, you can distribute the exponent. You don't have any adding or subtracting inside here. So 3 to the third power would give me back 27. X to the third power gives me back x to the third power. 64 is 4 to the third power. So when we substitute into our equation, or I'm sorry, our expression for how to factor this, your a, and this is going to be a little trickier, is 3x, and your b is going to be 4. So when you put that in there, a minus b is 3x minus 4. Now, a squared, this is tricky, is going to be 3x, the whole thing squared. So I have to square the 3 and the x. So this is going to give you 9x squared in that factored form. The term in the middle is a times b. So 3x times 4 would turn into 12x. And the term on the end, b squared, 4 squared is 16. And this would be my answer. And if you guys wanted to go through and check, you can. But I would at least tell you, let's check the first term here. 3x times 9x squared would give me back that 27x cubed. And on the end, if you do negative 4 times 16, you're going to get that negative 64. And all the other terms in the middle should cancel out just like they did when I showed you guys if I multiplied that back out on that last question. Okay, last one for difference of cubes here. I don't notice 4 or 108, either one on that list. So just like any question that you're trying to factor, you should always see if you have a greatest common factor that you could pull out in front first. So I'm just going to grab my calculator here real quick. I'm going to see if 108, I know they'd both be divisible by 2 at least, but let me see if that's divisible by 4. And it is. It's 27. So I'm just going to take one step before I factor this and pull a 4 out in front. Then I really get x cubed minus 27. Now, the factored form of this would need a 4 out in front. Your a value, whoops, sorry, this is really x cubed minus 3 cubed here. So a is going to be x, b is going to be 3. So this would factor into x minus 3 times x squared plus 3x plus 9. And if I'm just writing the factored form and I take a greatest common factor out in front, I do need to leave that there. Okay, now the sum of cubes is extremely similar. The difference is sum means I'm adding, so I'm going to have two things that are cubed and in between them an addition sign. Now the factored form for this is just a little bit different. It's a plus b, and then we've got to get those terms to cancel out in the middle, so it's going to be a squared minus ab plus b squared to do that here. So again, it's the same process. You got to figure out what you're taking to the third power. So here, this is x to the third. 125 is 5 to the third. So my a value is going to be x in that formula, and my b value is going to be 5. So I'm just substituting this in to get the factored form. Should be x plus 5. A squared is going to be x squared. A times b is going to be subtracted here, so it's going to be x times 5, or we would write that with the number in front for 5x. And then b squared is going to be 25. And again, you can check this if you want to by multiplying it back out. That should be your factored form. I don't have the list displayed on the screen, but hopefully you guys can look at this on your paper. 64 is 4 to the third power, and 729 is 9 to the third power. So here my a value is 4x and my b value is 9. So when I substitute that in, 4x plus 9, and people always have trouble with this, but that first term is a squared. So you have to square the 4 and the x. So this is going to be 16x squared. And if you want to check that real quick, 4x times 16x squared will give you back the 64x to the third. So that's right there. Okay, in the middle, a times b, 4x times 9. Just going to do, whoops, sorry, subtraction sign. 4 times 9 is 36 with an x. And then b squared is going to be 9 squared for this question. So this is going to be 81. And again, if you want to do a quick check, 9 times 81 will give you back that 729. This is subtraction here in the middle. Okay, and then one more real quick. I noticed both of these are divisible by 2, and both of them are divisible by x. So let's pull that out in front first real quick. Left over, I've got x to the third plus, this would just be 1. Now this throws people off all the time. But 1 to the third power is actually 1, so this is a sum of cubes here. So keep that 2x out in front. This is x to the third plus 1 to the third. So I'm going to keep that 2x out in front, and then in that factoring for a sum of cubes, my a is going to be replaced with x, and my b is going to be replaced with 1. So here's what I want to do here. Keep the 2x out in front. That needs to be part of the factored form. Then it's a plus b, so x plus 1. A squared would be x squared minus ab. That would be x times 1, so it's just going to be minus x. And then b squared on the end would change that to be a plus 1. So this is the factored form of that last question. Okay, now what is this used for? So we're actually going to solve equations. So you're going to see on the back here, each one of these problems is the same setup as we had on the front, except it's equal to 0. So you always want to set these equal to 0 to solve. Now, what I put at the top is just a copy of those two little factoring formulas I gave you on the front so you could see them. This says you always need to use the quadratic formula when you solve a question like this because two of the roots are going to be imaginary. So maybe don't do this on your paper, but if I actually just sat here and I was like, oh, okay, I'm just going to solve this. Negative 216 equals x to the third. We'd take the cube root of both sides to solve this, and this would be negative 6 and this would be x, and I'd have my answer, and people would stop there. The problem is, if you guys remember from when we were talking about this last week, if I have x to the third, that means this question has 3 answers automatically. I know that. So if I just go through and solve this, I'm like, well, crud, I only have 1 answer. Where are the other 2? What you'll have to do, and this is just the same situation for every single one of these, you're going to have to use the quadratic formula to get the other 2 answers, and that is going to cause you to have 2 imaginary solutions. So you'll have a real answer for one of these. For this one, it's going to be negative 6. But the other 2 answers, if you have a sum or difference of cubes, will always be imaginary. So let me go through, and I'm going to actually solve this the correct way. So let's do the factored form here. So this is x cubed plus 216 is, 6 to the third power. So I'm going to factor this like we did on the front. So your a would be x, your b would be 6. This would factor into x plus 6. X squared, a times b would be 6 times x. B squared would be 36. Okay, now, we already knew this, that negative 6 is one of our answers. I already knew that from what I did up there. If you looked at a graph of this, it would go through negative 6, but the graph would not go through any other points because the other 2 solutions are imaginary. So what you're going to want to do, and if you really wanted to, you could set this equal to 0 and complete the square, but I would just recommend the quadratic formula on this. So if you don't remember the quadratic formula, I'm going to write it here really quick. Opposite of b plus or minus square root b squared minus 4ac, everybody over 2a. And not to be confusing or anything, but it's either this is equal to 0 or this is equal to 0. So if I set x squared minus 6x plus 36 equal to 0, what would the answers be? Well, I can get those from the quadratic formula. You will never be able to factor that because the answers are always going to be imaginary. All right, now these a and b and c values are the quadratic formula. They're not from the factoring of this sum of cubes, so try not to get that mixed up. I'm not trying to confuse you. In this problem, I'm just looking at what I've got highlighted. My a value would be 1. B is going to be negative 6, and C is going to be 36. So that's what I'm going to plug into the quadratic formula here. So opposite of B would actually be positive 6 plus or minus square root negative 6 squared 4 times 1 times 36. Everybody over 2a. So negative 6 plus or minus. Now I'm going to just grab my calculator to do under the square root there here real quick. So if I do negative 6 squared minus 4 times 1 times 36, I'm going to get negative 108. And getting a negative, that's my discriminant, right? I know I should have two imaginary solutions to this. So this is negative 108. Okay, now I promise you, if you are doing sum or difference of cubes, anytime, this is never going to be a perfect square, but it will always be divisible by 3 in a perfect square. So I'm going to leave a little space here. If I want to break down that negative 108, feel free if you want to use a factor tree, but I promise you, if you take that number and divide it by 3, it will always be a perfect square if you're using a sum or difference of cubes. So my breakdown for this, I'm going to do negative 36 times 3. And remember, negative under the square root we're going to pull out as an I. So when I put that back in over there, the simplified version, negative 108 under the square root, is going to be 6i radical 3. So 6i radical 3 here. Everybody over 2. Now, don't be touching that radical. If this number, and this number have any common factor, you can reduce that fraction. All right, don't touch this. If all 3 of these have something in common, you can reduce that, and it's just going to depend on the question. Sometimes you might be able to do that, sometimes not. So these are all divisible by 2, so I'm going to reduce that. Do not touch the radical. You cannot reduce that. This is not the number 3. This is the square root of 3. So when I get down here, I'm going to change this. This is going to be negative 3 plus or minus 3i. The denominator would be gone because I'm going to divide everything by 2, so that would just turn into a 1. And my other 2 answers to this question, negative 3 plus 3i radical 3 and negative 3 minus 3i radical 3. So my answers to the actual question here, I've got the negative 6, we got all the way back there at the top, and then I've got what we got when we simplified the quadratic formula. So 1, 2, 3 answers here. I'm going to go through one more with you, and then I'll have you guys try the one at the bottom on your own. So this one will be a difference of cubes in the question next to this. So I look at this problem and I immediately know I'm going to have 4 answers to my question because it's x to the 4th. What I want to do first here is take out any greatest common factor, which I notice both of these terms are divisible by 2 and also an x. Left over, I'd have x cubed minus 27. All right, so my factored form, you got to keep that 2x out in front. Your a value here, I'm going to kind of write it above here. This is x to the 3rd minus 3 to the 3rd. So my a is going to be x, my b is going to be 3. So this will be factored into x minus 3, x squared plus 3x plus 9. All right. And then one of my answers here is going to be 0. You can see that in the original problem. If I plug in 0, that wipes out both of those terms. So there's one answer. This, to get that to be 0, would be positive 3. There's a second answer. And then I promise you, you're not going to find factors of 9 that add up to 3. You'll never be able to factor this. It has to be, again, if you wanted to use completing the square, I wouldn't recommend that, especially here because you're going to end up with a fraction because your b value is odd. But you're going to want to use, I would recommend, the quadratic formula to get your other 2 answers. All right, so all 4 of these things multiplied together to get 0. Either this has to be 0, so to make that happen, it'd be 0. This has to be 0. To make that happen, it'd be 3. This has to be 0. We have to use the quadratic formula to figure it out. A would be 1, B would be 3, C would be 9. So I'm just plugging it in. Hopefully you guys can still see quadratic formula over here. So negative 3 plus or minus square root 3 squared 4 times 1 times 9. Everybody over 2 times 1. If you, I'm going to grab my calculator here real quick. Under that square root, I'm going to have 3 squared minus 4 times 1 times 9. And I'm going to get negative 27. So negative 3 plus or minus square root. This will always be negative, and it will always be divisible by 3 and a perfect square. So if we're going to break down that negative 27, or the square root there, let me not grab that color. Hold on a second. Okay, negative 27. This is, use a factor tree if you want, but negative 9 times 3. So it's going to be 3i radical 3 when I simplify that. That's what I'm going to sub in for that negative 27 under the square root. Slide you guys up here a little bit. Okay, so negative 3 plus or minus 3i radical 3, everybody over 2. Now, negative 3, 3, and 2 do not have any greatest common factor. So I can't reduce this. This is just going to be my other set of 2 answers here. So negative 3 plus 3i radical 3, negative 3 minus 3i radical 3, all that both over 2. So you have 1, 2, 3, 4 answers to your question. Anytime you have a sum or difference of cubes in your problem, 2 of the answers are going to be imaginary. All right. Now, I'm going to pause this. You try the last one and then go back and look at what I did. I'm going to pause mine. All right. Hopefully you pause that. I'm going to go through what I've done so far. So 1,000 is 10 to the third, and then the x to the third. 343 is 7 to the third, so I rewrote that. So when I plug this into my sum of cubes here, my a is going to be 10x, my b is going to be 7. So I had 10x plus 7. Now, a squared is going to be 100x squared. Middle, you've got a times b, so it'd be 10 times 7, 70 with the x, and then b squared is the 49. Right here out in front, the real answer here is negative 7 over 10. And then the rest of this is the quadratic formula. So I just plug this in. 100's my a, negative 70's my b, and 49's my c. Now, I'm working with a lot larger numbers here as I go through, and I got this negative 14,700. I promise you, if you are ever working with a sum or difference of cubes problem, if you have to solve by factoring that quadratic that you're going to have, it will always, always, always be divisible by 3 in a perfect square. You're always going to have a 3 in the square root under this, or sorry, 3 under the square root in these answers. So I just took this, divided it by 3 on my calculator, and then automatically this is a perfect square. So I took the square root of 4,900, that was 70, and then to take care of the negative, I put the I with that. So now I'm going to go ahead and put that back in place over here and just show you guys how I would reduce this. So we have 70 plus or minus 70i radical 3, everybody over 200. So these guys are all divisible by 10. Okay, so I'm only looking at the 70, the 70i, and the 200. Don't touch that radical. Leave that alone. So if I divide each of those by 10, I'm going to get 7 plus or minus 7i radical 3 all over 20. And then 7 and 20, they don't have anything in common. So I can't reduce that any further. I have one answer here and the other 2 here, so I get a total of 3 for my fundamental theorem, because I should have 3 answers if I have an x cubed as my highest power, and just leave it right like that if you can't reduce it any further.